We discuss another technique of integration, which is called integration by trigonometric substitution. The idea is to transform an algebraic integrand into a trigonometric one, which is readily, if not easily, integrable. It results to a trigonometric function. And this trigonometric function is converted back into an algebraic function by using the substitution used earlier. The algebraic functions include the expressions a squared plus u squared, a squared minus u squared, and u squared minus a squared. So, for an integrand, containing the terms a squared minus u squared, a squared plus u squared, and u squared minus a squared, use the following substitutions. U equal to a sine of theta for the expression a squared minus u squared. And for integrand containing the expression a squared plus u squared, we use the substitution u equal to a tangent of theta. For the radicand or integrand containing u squared minus a squared, we use the substitution u equal to a secant theta. Whenever we introduce a new variable, we also have to change the differential. So hence, we'll be using the differential du equal to a cosine theta d theta. For u equal to a tangent theta, du is a secant squared theta d theta. And for u equal to a secant theta, our du is a secant theta tangent theta d theta. Alright, so let us take on some examples. Start with the integral of the square root of 4 minus x squared all over x squared dx. The radicand contains the expression 4 minus x squared, which is in the form a squared minus u squared, where a is equal to 4 because, a is equal to 2 because a squared is 4. Our u is x from u squared equal to x squared, and the differential of x is dx. So taking the differential of u equal to x, that will be du equal to dx. We then apply this substitution to our integral. So we have the square root of 4 minus our x here is our u, so the substitution that we will use is u equal to a sine of theta, or x equal to 2 sine theta. Taking the differential of x is dx, and the differential of 2 sine theta is 2 cosine theta d theta. So our x is 2 sine theta squared, or quantity squared, all over x again is 2 sine theta quantity squared. Our dx is 2 cosine of theta d theta. Our radicand becomes 4 minus 4 sine squared theta after squaring 2 sine theta. And then the 2 will cancel. We have cosine theta all over sine squared theta. Okay, by the way, this is 2 squared, so that will be 4. There will be 2 in the denominator. Okay, and then factoring 4 in the radicand and then taking its square root, that will be 2 square root of 1 minus sine squared theta over 2 sine squared theta cosine theta d theta. Okay. We can cancel the 2. Continue here. We know that 1 minus sine squared theta is equivalent to cosine squared theta. And then taking its square root, that is equivalent to cosine theta times cosine theta d theta all over sine squared theta. Cosine squared theta all over sine squared theta is cotangent squared theta d theta. So our integrand, originally square root of 4 minus x squared over x squared, now becomes cotangent squared theta. So for cotangent squared theta, it falls under case 1 for powers of tangent and cotangent. We shall apply here the identity 1 plus cotangent squared equal to cosecant squared. So cotangent squared theta will become cosecant squared theta minus 1 quantity d theta. We integrate cosecant squared theta, which is negative cotangent theta, and negative d theta is negative theta plus c. So the integral of cotangent squared theta d theta is negative cotangent theta minus theta plus c. The question is, how do we put back the original variable x? So to do that, we go to the substitution we made earlier. Let us construct a triangle, a right triangle, where the acute angle is theta. Alright, so from x equal to 2 sine theta, that means that sine theta is equal to x over 2. Definition of sine theta for a right triangle is opposite over hypotenuse. So for this right triangle with the acute angle theta, the opposite side is x and the hypotenuse is 2. We can now determine the third side using Pythagorean theorem. That will be equal to the square of the hypotenuse minus the square of the other side, x. So that will be 4 minus x squared. So from this triangle, we can now determine the equivalent expression for cotangent theta in terms of x. Cotangent, by definition, is adjacent, which is the square root of 4 minus x squared all over the opposite side, which is x. And theta from sine theta equal to x over 2, that means the theta is equal to the arc sine of x minus 2. So minus theta, or arc sine of x all over 2 plus c. For our second example, let us evaluate the integral of the square root of 1 plus 9 x squared dx. The integrand is of the form a squared plus u squared, where a is equal to 1 and u equal to 3x. So we shall use the substitution u equal to a tangent theta, or 3x equal to 1 tangent of theta. The differential is 3dx equal to secant squared theta d theta. So applying this to our integral, square root of 1 plus 9x squared will become 1 plus 9x squared is the square of 3x and the square of tangent theta, or tangent squared theta, while dx is 1/3 secant squared theta d theta. 1 plus tangent squared theta is equivalent to secant squared theta, and its square root is secant theta, times 1/3 secant theta d theta, or equivalently, that is 1/3 of the integral of secant squared theta d theta. We can readily evaluate the integral of secant. No, this becomes secant cube actually. Secant cube. So since the exponent of secant is positive odd, we shall apply here integration by parts, and we have done that before. And the integral of secant cube theta is 1/2 ln of, or rather 1/2 of secant theta tangent theta plus 1/2 of ln of the absolute value of secant theta plus tangent theta plus c. Or that is 1/6 secant theta tangent theta plus ln of the absolute value of secant theta plus tangent theta plus c. So to return it back to its original variable, from our substitution earlier, 3x equal to tangent theta, where tangent theta is 3x all over 1, using the definition of tangent, that is opposite over adjacent. So as done earlier, we construct a right triangle where the acute angle is theta, opposite side is 3x, and the adjacent side is 1. By Pythagorean theorem, the hypotenuse will be 1 squared plus 3x quantity squared, or just 1 plus 9x squared. So for secant theta, that is hypotenuse over adjacent. So the hypotenuse is 1 plus 9x squared over the adjacent, which is 1, times tangent, opposite, all over the adjacent, again 1, plus ln of the absolute value of secant theta, which is the square root of 1 plus 9x squared, plus tangent theta, 3x over 1, plus c. Or that will be 1/6 times 3 x square root of 1 plus 9x squared plus ln of the absolute value of the square root of 1 plus 9x squared plus 3x plus c. As our third example, let us evaluate the integral of the square root of 4x squared minus 1 all over x dx. So we start with the radicand 4x squared minus 1, which is of the form u squared minus a squared. So clearly, our a is 1 and u is 2x. So for u squared minus a squared, we use the substitution u equal to a secant theta, or 2x equal to 1 secant theta. Getting the differential, that will be 2 dx equal to secant theta tangent theta d theta. So the square root of 4x squared minus 1 by squaring 2x equal to secant theta will be equivalent to secant squared theta minus 1 all over our x. Our x here will be 1/2 of secant theta. 1/2 secant theta. Our dx, on the other hand, will be 1/2 secant theta tangent theta d theta. 1/2 secant theta tangent theta d theta. So we can cancel 1/2 as well as secant theta. Then the square root of secant squared theta minus 1 is actually equivalent to tangent theta, because secant squared minus 1 is tangent squared theta. Taking its square root, that will be tangent theta times tangent theta d theta, or tangent squared theta d theta. For tangent squared theta, we shall apply an identity. In particular, 1 plus tangent squared equal to secant squared. So tangent squared theta will become secant squared theta minus 1 d theta. And that will be equal to the integral of secant squared theta d theta, which is tangent theta. And d theta is theta plus c. To get the final answer, we construct again a right triangle. It says here that 2x is equal to secant theta, or secant theta is 2x over 1, which is equal to the hypotenuse over the adjacent side. So the hypotenuse is 2x, the adjacent side is 1, the other side will be equivalent to the square root of 4x squared minus 1. So from this triangle, we can get the definition for tangent theta, which is opposite over adjacent, or the square root of 4x squared minus 1 over 1. And theta is, from secant theta equal to 2x, theta will be arcsecant of 2x plus